Dear students, my name is Anjaneyulu. Today I am going to explain the topic of kinematics 1D. Today we will discuss about the kinematics 1D, one dimensional, the horizontal motion. So one dimensional means the body is moving in a straight line or horizontal motion. So before going to this topic, I will explain some few words. First of all, what is the particle? First of all, what is the particle? An object of negligible mass is called a particle. An object of negligible mass is called a particle. An object of negligible mass. So is called a particle. An object of negligible mass is called a particle. Next, body. A group of particles is called body. It may be depends on the dimensions like shape, and different shapes are there. So here these two terms are very important in this lesson. Particle, an object of negligible mass is called a particle, and body is the group of particles is called a body. So these two definitions is very important. Next, I am explaining mechanics. So mechanics. The branch of physics which deals with the motion of non-living objects is called mechanics. See, I will write in this definition. The branch of physics which deals with motion of non-living object in everyday life is called mechanics. All of you see clearly. The branch of physics which deals with the motion of, this term is very important. The branch of physics which deals with the motion of non-living objects in everyday life. You can see that in everyday life non-living objects. So what is the non-living objects? Chair is one of the non-living objects. Table, doors, and anything, whatever it may be in the world. Non-living objects. The branch of physics which deals with the motion of non-living objects in everyday life is called mechanics. So next I am going to explain. So what is the definition of the kinematics? So mechanics is completed. Now I will explain what is the kinematics. All of you keep concentration. So kinematics. So kinematics may be 1D, 2D, 3D. But in this class we will discuss about only 1D, one dimensional. One dimensional means which bodies are moving on the straight line, moving on the road. So that is called kinematics 1D. So kinematics means the branch of physics, the branch of mechanics which deals with motion of objects. See, I am writing on the board. The branch of mechanics. The branch of mechanics which deals with motion of bodies without taking into account of cause of motion. Is called the kinematics. So all of you see clearly the branch of mechanics which deals with the motion of bodies without taking into account of cause of motion. Here this letter is important. Without taking into account of cause of motion. So for example, any body moving. So for example, I am moving here to here means, so some external force will be applied. So here external force will be absent. So without taking into cause of, without taking account of cause of motion. So here force will be external force. Force is 0. So here external force is 0. So that is called kinematics. So the branch of mechanics which deals with the motion of bodies without taking into cause of an account of motion. So here external force is 0. So that is called the kinematics. Next here I will explain the dynamics. So dynamics. This basic terms is very very important. Next dynamics. See, kinematics and dynamics both are relative terms. So dynamics is the branch of mechanics which deals with motion of taking with cause of motion. So in the kinematics means without cause of motion. Here dynamics is with cause of motion. So little bit changes only. The branch of mechanics which deals with the motion of bodies taking into account of cause of motion is called dynamics. In previous definition, external force is 0. Here external force is not equal to 0. In kinematics, external force equal to 0. Here in the dynamics, in this condition, external force not equal to 0. Some external force is there. Here see the branch of mechanics which deals with the motion of bodies taking into account of cause of motion. In kinematics without cause of motion, here dynamics with cause of motion. This little bit changes only. Don't get confusion. So these two terms is very very important. And next I will explain the two terms. In these two terms, the entire lesson is very very important. In the kinematics, not only 1D, 2D and 3D also you can use very very important terms. Restive and motion. So restive and motion. Rest and motion. These two terms is the relative terms. rest and motion. These two terms is the relative terms. These two terms is very very important. So first of all, what is the rest? What is the rest? If position of a body do not changes with respect to surroundings and time is called the rest. If the position of a body changes surroundings, do not changes surroundings. So I will write definition. If the position of a body do not changes with respect to surroundings and time, then the body is said to be in rest. If the position of a body do not changes with respect to surroundings and time, then the body is said to be in rest position. So these terms is important here. Do not changes. So for example, I will explain one example. The bus is moving on a straight road. The bus is moving in the straight road, moving this direction, and two persons sitting in the bus. First person name is the A, second person name is the B. It is two persons sitting in the bus is moving in the straight road. So here A is observing to the B. A is with respect to B in the rest position. Because of but bus only moving, but these two persons only sitting in the bus. So A is observing B. A is the rest position with respect to A. B is the rest position. With respect to B is the rest position. So position do not changes. One more example I will explain. For example, just imagine I will take this duster keep on my hand. This one is rest position or motion. Unless until this one is in rest position. So when I am applying some external force, this body will be moving. I am not applying external force, this body continuously. Anytime you can see this one is in rest position. So that is the example of rest. If the position of a body do not changes with respect to surroundings and time is called rest. So that is the rest. And next I will explain the motion. Rest and motion both are relative terms. Just little bit only we can change in the definition of the rest. Motion. If the position of a body changes with respect to surroundings and time is called motion. If the position of a body changes with respect to surroundings and time is called motion, and the body is said to be in motion. Now see, if the position of a body changes with respect to surroundings and time, then the body is said to be a motion or is called motion. See same example. The bus is moving this direction and third person is there. We are involving third person. The third person name is the C. First person name is the A, second person name is the B, and third person name is the C. So in previous condition, A with respect to B is the rest position, B with respect to A is the rest position. But here we are involving the third person. The third person name is the C. C person observing both A and B. C person observing both A and B. Both A and B is in motion. Both A and B is in motion because of he is in the outside of the bus. These two persons only sitting in the inside of the bus, but C is sitting in the outside of the bus. So that's why here these two persons with respect to C, C will be observing. So these two persons in the motion. So here position will be changes. So sometimes now here observe is for example, this is the 10 a.m. I think just imagine and exactly just imagine. So 10 a.m. started the bus. For example here I think this is the Gauhati. So after we can observe the same bus, position will be changes. So after we can observe after 5 hours, this bus maybe get I think Shillong and another place. So position will be changes. The position of a body changes with respect to surroundings and time. So one more example I will explain. See this duster keep on this like this, my hand, I am moving like this. Position will be changes. Here the board is here see I am near to the board. This car I am near. After some time I am moving like this. I am near to this car now. Because of here see the position will be changes. That position to I am came to here. Here the position will be changes. So that is the definition of the motion. If the position of a body changes with respect to surroundings and time is called motion. These two terms is the very important in this total lesson. Not only kinematics one dimensional and two dimensional and three dimensional. In this total lesson, these two terms is the very important. And next point path. This all is the definitions. Just all members keep on the concentration. So path. So path is nothing but the line joining of successive positions of all particles. The line joining of successive positions of all particles. So for example here the particle A, the particle B, the particle C, the particle D and the particle E. Some particles there. See, so what is the particle? Starting class I will explain what is the particle. An object of negligible mass is called a particle. An object is a negligible mass of is called a particle. So here some particles are there. So what is the path means? The successive the line joining of successive positions of all particles. So the line joining like this. This is the path. So this is the initial path. This is the final path. I think this is the initial point or this is the final point. A is the initial starting point, E is the ending point or final point. So what is the path? What is the path definition? The successive positions of all particles, the line joining. So we can join all particles. So like this is a successive. Successive means after points. The line joining of successive positions of all particles is called. We can join all particles. That is called a path. This is the initial path. This is the I think this is the initial point. This E is the ending point or final point. That is about path. Next, I will explain. Very important. These two terms is very important in this total lesson. Distance and displacement. Distance and displacement. Distance and displacement. Before going to, I will explain this one, distance and displacement. I will explain small two terms. Scalar quantity and vector quantity. Scalar quantity and vector quantity. First of all, I will explain the scalar quantity. What is a scalar quantity? So these letters we can number of times in our lessons when you are reading. I think we are reading some lessons. We can listening. Distance is a scalar quantity. Displacement is a vector quantity. You can hear number of times. So what is a scalar quantity? So scalar quantity has only magnitude. The physical quantity which has only magnitude is called a scalar quantity. The physical quantity which has only magnitude is called scalar quantity. Scalar quantity. See, the physical quantity which has only magnitude is called a scalar quantity. So, for example, when we are going to the market, I think we are asking some. Please give 4 kg sugar and 5 kg tomato. Like this, we can ask only. So, no need of direction here. So, we are asking only quantity only. You can ask. When you are going to the clothes also. So, give for when you are going to the shops means you can ask give 4 liters oil, give 4 liters water, and give 5 liters sugar. I think anything you can ask. So you can ask only quantity only you can ask. So no need of direction here. That is a physical quantity. That is the scalar quantity. Scalar quantity means the physical quantity which has only magnitude. So it has only magnitude. This is important. Only magnitude. So no need of direction here. So is called the scalar quantity. Next one I will explain the vector quantity. Next one I will explain the vector quantity. Vector quantity. So definition of vector quantity: the physical quantity which has both magnitude and direction. The physical quantity which has both magnitude and direction. The physical quantity which has both magnitude and direction. So is called vector quantity. So for example, how many directions are there in the world? We have 4 directions: east, west, up is the north, down is the south. East, west, north, south. For example, this is the table. Keep one book on the table. So this is, I think, black. Is one table is there. I will take one black keep on the table. So my friend is telling to me, you can apply some force. You apply some force means so force means you can force will be applied, but need of direction also important. Need of direction also. Which direction you can apply force? East direction, west direction, north direction, and south direction. So that is the force is examples of the vector quantity. So you can apply forcing, but okay. So which direction you can apply? 4 directions are there: east to west to north to south. So for example, I am applying some this direction, south direction, and east direction, west direction, and north direction. So vector quantity must should direction important. Without direction, this one is it is wrong. Without direction, vector quantity will be wrong. So vector quantity is represented like bar. Vector quantity is represented like bar. This is called like a bar. I think distance is the letter is the S, and displacement is the S bar. The remaining points we will discuss about next class. Thank you for watching, all of you. Dear students, once again, see today class, total class. I will repeat total class. So first of all, we will discuss our topic name is the kinematics 1D. Kinematics 1D. So what is meant by 1D? Which bodies are moving in a straight line? Which bodies are moving in the straight road? That bodies you can study. That is the kinematics. So kinematics means horizontal motion. Kinematics means horizontal motion. Particle is completed. Particle and body and mechanics and rest and motion and path and scalar quantity and vector quantity. These points I will complete it. So next class we will discuss about remaining points. Thank you for watching. Thank you once again.